Hello everyone, good morning, good afternoon. So today we're going to learn about microservice architecture and its related components. So I'm going to give you a high level overview for different components what are involved in end-to-end architecture or end-to-end application. So as you look at this diagram, so it will clearly says that what are the applications comes in what stage and how the request is going to navigate. So I'm going to tell you the what all the individual products or APIs which are available to use these things and what is the open source and other things are available to use as a part of this whole architecture. So if you see that the client request, which will be basically if you see that from the any browser or your laptop, mobile, whatever it is there. So whenever you make a request, so particularly, so it will be go to the some set of you can call it a firewall or registry, load balancer, API gateway. So where you will have that front-facing applications or front-facing systems, where it will be called as a API gateways, where you have a registries, where you have a load balancer. So API gateways is nothing but where you are going to have that all your routing process where is going to so that you are going to mask your actual URL of your services, actual URL services, and it is going to give you the proxy URL so that client doesn't know which one to or what is actual URL of it being used there, because it's masked that it's a gateway, so it's a front door for your request. So from there it will redirect to the particular services based on the configuration and based on the request. And the service rest is like in microservice applications. So you might creating n number of microservices and you want to know each address of the each microservices. So if you try to configure each every IP and everything, it is going to be very complex or very tedious to maintain all those things. So you can create aliases and register to a single system where all the microservices are defined in the whole end-to-end architecture is available. So that gateway will make a use of that registry and redirect that particular request to particular microservices which is based on your request, whatever the request parameter or whatever the request path is defined over there. So now the load balancer is something like it's like you have a multiple instance of a same microservice or multiple microservices. So if it is one is down something and it has to request has to rotate to other one, so based on your configuration, so load balancer will perform that particular activity. So if you look at that particular activity, so you have a different load balancer, if a different service registries API gateway in the market, and then you can use the some of the free sources. You can see the Netflix Eureka architecture. It will provide all that Zul gateway, Ribbon, Hashtag, Resiliency 4J, and everything. So if you look at that different options with what we having it here, for the example, so Netflix, Eureka, and Spring Boot are the well-known architectures which where or well-known technologies being used in the microservice in Java world. So that you have a API gateway, service and load balancer created on that. So here I just created as a three different steps here or three different boxes here, because just to make sure that we are capturing all those things. So it can be like your API gateway itself is act as a API registry when you make yourself own your API gateway or registry, then load balance you can configure in that itself. Like a bit depends on how you want to use the different applications, and if you're using some third party like AppGs itself is can act as a API gateway and as well as the load balancer, and you can have a different service registry like Eureka service registry or service discovery for yourself created. So it depends on your use case or how your architecture, how you want to create each and everything. So once the request is sorted out with all the defined configured rules here like a API gateway, service registry, load balancer, everything. So based on your configuration and your rules, the request will be redirected. For example, if the load balancer is based on your geolocation or based on your payload size, so everything, so that rule is configured. So if something has to be triggered to go to service one, or something has to go to service one replica, or maybe some other instance of service one, so that it will be configured in the load balancer as well. So you can use the PCF FI load balancer which is inbuilt. So it's, as I said, it's a default what you want to configure it here based on your use case and based on your application and your application architecture. So once the requests come to the each individual microservices, so the advantage as here is like you can create with the different technologies or different languages, each microservices can act as a independent services. Definitely that is the advantage of microservice, so that you can create with the different languages, different set of teams and everything where that. So if you see, each microservice will have to work with the database what you're going to work on. Like now currently in the market, like you have a SQL, no SQL databases, of course. Like SQL, you have MySQL, Oracle, PostgreSQL, lot others as well. And in the NoSQL, you have a MongoDB, Cassandra, and other things as a CockroachDB and a lot of other things. So based on your requirement, you can use SQL or NoSQL based on your use case. You can use that. So each microservice will talk to the database, and the general convention or best practice is to have each individual microservice will have a different set of or individual databases to interact with. So other important part is the cache. So nowadays the cache plays a very important role in your application, so that your application is fast loading and you can store very critical data which can be fetched very easily, so that your application load time is reduced, so that you have a Redis cache, MA cache. So everything, these all the caches will be used, so that this is one of the most necessary part of your design to use the cache. And another one is like messaging queues. So if you nowadays, like, messaging queues are a very integral part of the microservices architecture. So you can use a Kafka, ActiveMQ, RabbitMQ, any of the messaging queues which use. So queues are also used to interact between like microservices based on your architecture, as I said earlier. So you can use the queues and other things how you want to interact, or you can use a fan client, you can directly connect with that, or you can interact with a, as I said, like service registry gateway. So it will go back to your gateway and route the request back to the particular microservices. So it's just based on the your design of the architecture and how you want to use that point of a time for that use case, that's the matters the most here. And other things which is like Elasticsearch, where you're going to search your logs, you maintain all the text search and everything. So Elastic is free and it's used. Splunk is also there along with Elastic, but it is a paid one. So Elastic is very much in use in the market now. Different. So you have a DevOps, like you have a Jenkins build, you have other builds, harness, and other things where you can use a DevOps to uh, uh, for end-to-end application development and deployment and continuous integration and continuous development. And the GitHub, definitely the GitHub to store your files, to develop your repository for everything which we want to use, other things, and your IDs, everything. So those are the other aspects of, just I want to mention here. These are the very important parts in your architecture or design, so that you will have an end-to-end system up and running when you have these, at least minimum of these systems or components are involved in your architecture. And one of the most important other things, as like some of the identity providers nowadays, you have a single sign-on and other things, or third-party libraries, where your clients will log into your system, so that you don't need to manage all those user ID credentials, everything, unless you want to. So that you can use a different set of identity providers like Okta. You have ClickHawk, you have Auth0, one login, single sign-on patterns and everything. So you can use that patterns whatever you want in your application and everything. So this is the high level components which are involved in your application, so that it covers end-to-end use cases for any of the microservice implementation. So in the coming videos, I'll just explain each and individual components, how it is used, and with the example and with a GitHub repository as well. And I added all the this documentation in or the blog, and I'll share that link as well in the description as well. I hope you got the basic idea of the microservice components which are used in the microservice architecture. Thank you. Thanks a lot.